Okay, the purpose of this screen recording is to demonstrate the use of the TI-Nspire for solving linear systems. And so this is the first page of your note, and I've already highlighted in the introduction a couple of key things. First of all, to solve linear systems by graphing on the calculator, what we need to do is isolate y, get the equation in the y equals mx plus b form, and what we're interested in, which is demonstrated in the first example, is the point of intersection between the two lines. So linear systems are lines, and we graph both of them and find the point of intersection. So what we're going to do now is work through examples 2a and b using your Nspire to demonstrate how to use it. Okay, so in example 2a, the first equation y equals 3x plus 2 is already in the form that we need it. What we have to start by doing is rearranging the second equation to isolate y. And so I'll begin by moving the x to the right hand side. 2y is equal to 11 minus x. And then I'm going to divide through by 2. And I'll be left with y equals 11 minus x over 2, which of course can also be written as 5.5 minus 1 half x. Just fix the denominator, minus x over 2. If you're going to use the 11 minus x over 2 form on the calculator, you must ensure that you put it in parentheses so that the calculator interprets the expression or the equation correctly. Okay, so now we're going to move to the calculator. As mentioned the first time we use it, what we need to do is open a new document. And so start off on your home page on the right hand side, which you can get to using the trackpad or the cursors. Go to new document, and what we're going to do is select number 2, add graphs. And so straight away it opens the entry line on the bottom with f1x, that is y. And so we'll enter in our equations. The first one is y equals 3x plus 2. So we enter 3x plus 2, hit enter, and it's going to draw the graph for us. And then what we're going to do is go in and enter a second equation. It's defaulted straight away to f2, our second equation. First equation is f1. And so in the f2 line, I'm going to enter using parentheses 11 minus x, and then move outside of the parentheses, and that is all divided by 2. Enter, and here we have our two lines graphed for us by the calculator. Just move the label out of the way. What we're interested in now is the point of intersection between those two graphs, and in order to find that, we're going to go into the menu, and number 6 is Analyze Graph, and the option we're interested in is number 4, the intersection. And so now what the calculator is asking for is a lower bound, as you can see on the bottom left of the calculator screen. And so the lower bound is a point to the left of the intersection point. And so any point to the left, I'll just click on, and then I'm going to move, and you see the area opening up and the word intersection appears. That means we've captured at least one intersection point. Later on, when we deal with polynomials, they'll have multiple intersection points, and this is the reason the calculator has this function. And so I've got an acceptable upper bound. I'll click on it, and what we can see is that our intersection point is now highlighted. And so the last step now would be to transcribe this onto the graph that's been given. We must be able to show work, and so the solution to the system is x equals 1, y equals 5, which of course is a coordinate point. And so I'll graph that point on the graph, and I'm going to use that to sketch my two lines. And so the first function, y equals 3x plus 2, we can see from our graph on the calculator has a y-intercept of plus 2. And so I'm going to just graph those 2 points and join them. That's the quickest and easiest way to draw a sketch of my graph. And I'm just going to use the line function just for neatness. And so we have our first function, and then the second function, as you can see from the screen, again, this is just a sketch, intersects the y-axis at approximately 5.5, and so, well, exactly 5.5 as we can see from the function. And so I'm going to go ahead and draw a second line passing through 5.5 approximately, and the intersection point. And now what I need to do is label my point of intersection and label my two functions. And so this is y equals 3x plus 2, and the other function y is equal to 11 minus x over 2. Actually, any one of the forms of the equation would be fine for the label. Okay, and that is the first example completed. What we'll do now is go straight on to the second example and begin by rearranging both of these into the form y equals. And so the first function is y equals minus 3x minus 4. And so we do that by moving the 3x to the right hand side, subtract 3x from both sides. Second function is going to be slightly more complicated to rearrange. We begin by moving the 2x term to the right hand side, and it becomes minus 2x, and we must then multiply the entire equation through by 2 in order to get rid of the fraction y over 2, and so this leaves us with y equals minus 4x. And so we now have our two equations, and we'll follow the same procedure as we did before. And we come back to our Nspire, and what we want to do is we don't want to clutter up this graph, so we're going to create a new graph. And if you look above the document button in blue, it says plus page, and so that's going to allow us to add a page to this document. And again, anytime you want to access the blue menu, what you're interested in doing is using the control button. And so control document, that's going to add a page, and once again we're adding a graphing page. And so you can use the tabs at the top to toggle between the two. 1.1 was the first example, and now we're graphing on 1.2, the second page. Okay, so we'll enter our functions. Minus 3x minus 4, again it's negative 3x, and so we use this negative button just below the 3, minus 3x, and then we're subtracting 4. That's our first function. So just double check. Oh, left the x out. Minus 3x minus 4. There's our first function, and then we'll enter our second function, which it's denoted as f4, and that will be negative 4x. Okay, and as we can see from here, we've got a point of intersection, or the graphs appear to be heading towards each other, but we cannot see the point of intersection, and so we're going to need to modify what is known as the window, and the window is what we can see on the axes. Here we have the x going from minus 10 to 10, and the y going from 6.67 to minus 6.67, and based on the behavior of the graph, what we need to do is be in the fourth quadrant, but much lower down, and so we need our lower bound of our y value to decrease. We need minus 10 or 20 or maybe even 30, and similarly for the x, we may need to increase that depending on where the point is. And so we have several different options. You can grab the axes and move them, although that is quite difficult using the trackpad. What I do want to show you, however, is using the menu, and what we have is number 4, which is window or zoom. And in the window or zoom, there are several different options. We can zoom out, but the one that's particularly useful is option A, which is zoom fit. And so I'm going to select that, and what it does is modify the axes so that it shows key points, and so in this case one of the key points of course is the intersection point, and so I'll just try and move our labels out of the way. There's our intersection point, which we can now go ahead and find using our menu. Okay, and so we are going to analyze the graph and select number 4, intersection point, left bound. Make sure we capture the intersection point. There's our right bound, and we have our intersection point, which is 4 minus 16. Okay, and so as we did with the previous example, we now need to come over to our graph and sketch that. You'll see that this graph has got no scale on it by design, and so we've modified our window, and we're going to need to adjust to label our axes accordingly. And so what I'll do in this case is go down in increments of 5, minus 20, minus 15, minus 10, minus 5, since we have our intersection point a y value of 16, and for the x there's no point in us or there's no need for us to modify our scale, since the x-intercept is at 4, and so 2, 4, 6, and 8, and so as we did before, I'll just mark off on the axis the point of intersection, which is the solution, and so that was x equals 4, y equals minus 16, and we have the point 4, and we'll just have to estimate on the graph where minus 16 is, and of course that's the other reason it's important to label key points. And so now from the graph we see our blue function, the y equals minus 3x minus 4, will have its second point of intersection near the minus 5. Again, I'll go and use the line function in order to sketch slightly more accurately, passing through those 2 points. And then our second graph passes directly through the origin, and so we'll go from the origin, passing through our point of intersection. We'll just make that a little bit longer, and now sketch the but label our graphs. And so the one passing through the origin is the function y equals minus 4x. The other function is y equal to minus 3x minus 4, and our point of intersection 4 minus 16. And that concludes the demonstration.